We are talking about superposition principle. Suppose you have three charges, 3-point charges, Q1, Q2, and Q3 in a system of charges. I will say it is plus Q1 minus Q2 plus Q3. Kept at the positions indicated. And there is one distance D1. Let us say there is one distance D2, another distance D3. Now, if you want to calculate the force acting on any of these charges, say Q3, what is it I have to do? To determine the force on Q3, I should know the force on Q3 because of Q1. Should know the force on Q3 because of Q2, attractive force. F2 because of Q2. And we should know that anyway side magnitudes of the sides are given. You can calculate the angle between these two forces, theta. You should know that or compute the angle between these two forces. And then determine the resultant of these forces using parallelogram law of vectors. I should look at the signs, polarities of the charges, compute the force using scalar law, keep it in the given direction, know the angle between these two forces, compute the magnitude and direction of it using parallelogram law of vectors. Say root f1 square plus f2 square plus 2f1 f2 cos theta. Magnitude. And then the angle of it as f2 sin theta by f1 plus f2 cos theta as a tan inverse of the alpha we will do. Compute the total force, resultant force using parallelogram law of vectors. Same is to be done to determine the force on Q2. When you talk about the force on Q2, because of F1 it is attractive. Because of F3 it is attractive. Because of which the force is this. This is the force on Q2. In the case of Q1, because of Q2 it is positive attractive. Because of Q3 it is repulsive. Because of which the resultant is along the diagonal of the parallelogram drawn. Check it. Resultant. We are talking about the superposition principle. I don't want to do problems here because that is not our requirement here. We are supposed to know things properly, fully well. Right? In the same way, If it is required, you can ask me, I can tell it. We can talk about the force on each charge in a system of charges kept at the corners of a square or rectangle. No, standard figures actually. No, check it. Very, very important point to which we are trying to come. Extremely important for you to completely understand it. Listen carefully. When later on we will name the topic accordingly. You should only tell. If I keep a charge of Q1, Q at a point, charge Q, a point charge of Q coulombs is kept at a point. At any point on the circle of radius R, having this point as the center, it experiences same force, and that force will be radially outwards, because at each and every point on this circle having the charge at its center, the second charge experiences same amount of force because of the magnitude, and because it should be along the line joining. All these directions can be in general put as on the plane radial lines. On the plane it is radial to the circle of radius R. Radial to the circle F is in a plane. Radial to the sphere in space. Correctly, no? In space, it is a sphere. At the center, you have the charge. Please try to understand that. Whether you consider a circle having the charge at its center or a spherical surface having the charge at its center, every point on the circle or every point on the sphere, the second charge experiences the same radial force because its distance is same. On the given plane, the field is circularly symmetric, and in the space, it is spherically symmetric. On the plane, the forces, statement to know, these statements matter a lot later. Forces circularly symmetric. In the space, it is spherically symmetric. Please check it. Same. And in circular coordinates, the force is everywhere radial, AR, ARO. And in spherical coordinates, the force is everywhere radial, denoted by AR. Even though the directions are different in Cartesian coordinate system, in the respective coordinate systems, even though they are different, they are named by the same vector. to exploit the advantage of using different semiconductor, say the coordinate systems, we should know this symmetry. Number one. Point charges create the field which is spherically symmetric in the space is what is one information to us. And the plane, it is circularly symmetric. Hope you are concentrating. Please check it once. I will consider a line, a straight line. Keep a charge Q. Consider a point at a distance R. Point is fixed. There is a small charge Q kept at that point. It experiences a force. Concentrating, right? You are concentrating. And that force, if Q and Q are both positive, I'm considering, right? The force is the repulsive force. And the net force on the charge P is horizontal. Charge at P is horizontal to the right. If I keep one more charge Q at a distance D from it, above, and another charge Q below it at the same distance D, the charge at P experiences three forces. The charges above and below the central charge will exert the force F of same magnitude, inclined at the same angle from horizontal. You're concentrating, right? If this is theta, this is also theta. We can talk about the formula of this also, the tan inverse of D by R. Correct? No? And the forces, definitely this force magnitude is what? This is actually what? Capital Q, small q by 4 pi epsilon R squared. I'm writing for your benefit. What is the magnitude of the force because of the Q below? Capital Q, small q divided by 4 pi epsilon. What is the distance? Distance is root R square plus D squared. Correct? Into R square plus D squared. The magnitude of this force because of the charge above also, capital Q, small q divided by 4 pi epsilon into R square plus D squared. I want you to respond quickly. The resultant of the forces because of the charge above and below symmetrically placed together create only horizontal force along the original first force. And the vertical component of these two forces together is zero because one cancels the vertical component of the force created by the other. You
So it should be what for 3 by 2, no, sir? R square plus D square.
ಹೌದಪ್ಪ
Root of ಬರುತ್ತಲ್ಲ ಸರ್?
ಹೌದು ನಾನು ಡಿಸ್ಟೆನ್ಸ್ ನಾನು ಸ್ಕೇಲರ್ ಫಾರ್ಮುಲಾ ಬರೀತಾ ಇದ್ದೇನೆ.
ಓಕೆ
ಓಕೆ ಅಂತೀಯಾ? ಅಷ್ಟು ಬೇಗ ಥಿಂಕ್ ಮಾಡು. The distance is root of D square plus R squared. This is where actually I expect you to concentrate more. You should be quick to think about small things first. because the distance, actually the line is the hypotenuse of the right angle triangle with sides D and R. The length of this distance, the magnitude of the distance is what? Root D square plus R squared. When I write the scalar form, what is it? Distance squared. The 3/2 will come in the vector form, not in the scalar form, distance squared.
Got it.
Net force is first one, second one. Listen carefully. If I continue to do this, one set of charges, one below, another above, another set of charges, other set of charges. If I put them in sets, let us say there are n sets of charges kept along the vertical line with the intercharge separation of D. I will have one more set for you to know. Having the magnitude capital Q small q divided by 4 pi epsilon R square plus the distance is what? R square plus 4D squared. Because now the vertical side is 2D. This distance is root of R square plus 2D whole squared. This also of the same direction, same magnitude because of the charge below. Because of the third set of charges, it will be capital Q small q divided by 4 pi epsilon R square plus 9D squared. Because of the next set of charges, it will be capital Q small q divided by 4 pi epsilon into R square plus 16D squared. You agree this? Please think about it now. Check whether it is clear or not. It goes on. I want you to concentrate more here because we are trying to understand very important thing. Why I am not doing these things for the sake of problems that come. These topics are not there for the sake of problems. You are supposed to understand them. If it is there in your semester, no actual course, then you may have to substitute, put the numbers and then do the problems also based on these concepts. Now I want you, please check it, to think about it. I want to know if there are many n sets of charges kept like this, what is the expression to compute the total force experienced by the charge small q? To calculate that, listen now. This is one force which is because of the charge q. I know the magnitude of it as capital Q small q divided by 4 pi epsilon R squared. Because of some ith set of charges, ith q set, these two forces are having the magnitude of what? First set D squared, ith set ID whole squared. Each force is of magnitude. What is the magnitude of this? Capital Q small q divided by 4 pi epsilon R square plus I squared D squared. First set I is equal to 1, second set I is equal to 2, That's what you can see, 4d squared, 9d squared, 16d squared is coming. What is the resultant of these two equal forces equally inclined from the horizontal force F? If this is theta, this is theta. The resultant of these two forces is 2 times the horizontal component of each force, right? Or the component along the actual force. Because of small q kept here. I have to write it as, if this is theta, I have to write it as 2 times capital Q, small q, cos theta by 4 pi into r square plus I squared d squared. What is cos theta in the figure? Because theta is not given to you as the data. This is I times d. This is r. What is this theta? Same as this theta's tan inverse of, or if I say cos of theta, what is cos theta? What is cos theta? Is equal to, if you can check it, 2 into capital Q, small q divided by 4 pi epsilon, 4 pi epsilon. Times. What is cos theta in this triangle? R by
root of
square plus I squared d square whole power 3 by 2. Now, cos theta is R by root of r square plus I squared d squared, correct? No?
yes, sir.
Definitely this magnitude is along the horizontal line in this particular case. What is the total force F, which is purely horizontal? Capital Q, small q divided by 4 pi epsilon r squared plus sigma summation I is equal to 1 to n 2 times capital Q small q r by 4 pi epsilon into r square plus I square d square whole power 3 by 2 is the formula to be used to compute the total force experienced by this small charge q. I want to put it like this. 2 is there, right? For the sake of extension of this topic. Capital Q small q divided by 4 pi epsilon r squared plus sigma summation I is equal to minus n to plus n, I not equal to 0. Or can I put I equal to 0 also? Yeah. Minus n to plus n, I not equal to 0, because I equal to 0 I already added. In the place of 2, what I am keeping is capital Q small q r by 4 pi epsilon into r square plus I square d square whole power 3 by 2. Check it once. Let us say I want to talk about second set of charges. I is equal to minus 2, I is equal to plus 2. Anyway, I squared is positive, because of which, whether it is I is equal to plus 2 or minus 2, you will get the same number in the summation, because of which it becomes twice. This is same as this being removed and this. If I put 2 in the sigma summation, I have to separate the I is equal to 0 case. There is only one charge. There are no 2 charges. Really, one of the very important things that you have to understand here. Check whether you are able to actually understand every statement that is coming here. It goes a long distance now. I assure you that the way in which we go will really motivate us a lot in the long run when you go into the subject, because we have studied all these things. It makes a huge difference in complete understanding of the fields, because we are not trying to understand fields as a subject, fields as the fundamental we are trying to understand. You should know. Is it okay? Any doubt here? Final. In this case of n sets of charges kept right around the central charge, this is central. If I consider a circle of radius r on a horizontal plane having the central charge q at its center, everywhere it experiences the same amount of force horizontally only. Which is along the radius to the circle. Do you agree? The radial force experienced, if I keep a charge q here or charge q here or charge q here at any point on this circle, it experiences the same force, because the vertical components of the forces, because of the charges one above one below, get cancelled out. It will be horizontal and it will be radial. Is it difficult to understand that it experiences only radial force? At any point on the circle, the formula is, the magnitude is same as F horizontal. On this circle, at each and every point, the charge experiences only horizontal force, which is along the radius to the circle, having the charge q at the center. Will the same thing happen? My question is very, very important and pertinent question here. I will now consider the horizontal plane passing through the charge below it and consider a circle of same radius. Will the charge q kept on at any point on the circle experience horizontal force only? Can we calculate the total force using the same formula? Please respond. No. What is that I have to do? Rahul Charan is telling vertical component will be there because I have come below. Listen carefully. This is basically giving me the first term, I is equal to 0. The resultant of these two is giving me for I is equal to -1 and +1. Resultant of these two giving I is equal to +2 and -2, next set of charges. Like that, I'll have n-1 sets, correct? Leaves one above as it is, right? There will the vertical component of the force because of the topmost charge will not be balanced by the opposite charge because it is not there. Because I came down once. Carefully look at it. If there are 3 sets, one set, 2 sets, 3 sets. At this point, this is horizontal. These two forces, they will cancel their vertical components. Correctly, no? 1, 2, 1 I came down. So, how many above? This is the central one. 3 above, 3 below. Now, if I come down by 1 charge, what is the formula to be spoken about? Three plus 7. How many vertical components remain unutilized? Respond if you try to understand this symmetry. 2. There was 7. If I come down, there are 2 below, 2 above, which is getting cancelled out. But these two horizontal components I have to calculate and then put it as a sum. And I have to add the vertical components of these two and take the vertical component of the force also. Very, very important thing is that the net force on this circle is not radial, right? It has radial component also. It has vertical component along with the radial component. If there are finite number of charges, only along the circle drawn on the plane containing the central charge, the vertical components because of the charges above and below get cancelled out and the net force becomes radial. But if there are infinitely many charges above and infinitely many charges below, what will happen? Last point for this symmetry discussion. If there are infinitely many charges above and infinitely many charges below, then it will be only radial because of what? When it goes to infinity, it is at infinite distance anyway. And we talk about, listen carefully, net force because of the charges here is purely horizontal. Because of these two n-2, you have horizontal components as well as vertical components. If I come down, if there are infinity, infinity minus 2 is infinity only. If I come below also, right, when I put them on the line, if I come down by so many values of n, so many values, if there are infinitely many charges above and below, n minus So many millions also still is infinity. So infinitely many charges are there above, infinitely many charges are there below, because of which one point I want you to, I will now give you a break for about 10 minutes. You have to think about it and tell me. If there are infinitely many charges on the line of infinite length, minus infinity to plus infinity, on this, if it is radial, purely radial, on this circle also I will tell that it is purely radial, and it is same because by a finite number that sum up till infinity gets reduced. Infinity minus some finite number, whatever, however large it is still infinity, because of which it will be same on the circle of radius r having the center on this line at any point. Ultimately, I say that if these charges are kept on a line of infinite length, and the number of charge sets that are kept is also infinity, at any point in the circle drawn on the plane perpendicular to the line, the field is purely radial, because of which at any point on the cylinder of radius r having the line as its axis, the field is radial, because of which the field, the force field that we are talking about now, because of the charge, because of infinitely many charges kept along a line of infinite length, irrespective of the distance between them, because of this charge, whatever the field created is cylindrically symmetric, in the sense on the cylinder of radius r having this line as its axis, the charge q experiences the same radial force at any point on the cylinder, because of which the field is cylindrically symmetric. With n is equal to infinity. That's all I can tell, extending the previous case. With n equal to infinity, the field created is cylindrically symmetric.